Hello, Jibers. We are a bit behind schedule on the Micronta multimeter repair, but nevertheless, I have some time to spend. I've been looking at the schematic for some weeks now and trying to have an idea how the circuit works and where things are, and some hunches and guess here and there. So I was in the cross section whether I should check this board or I should check this board first, because this board here is attached to the selector and it's harder to take out and put it back in, and furthermore it needs to be assembled for it to for any of the need to be assembled for the switch, the rotary switch, to touch whatever needs to be touched on this area of the switch jumper. So I was looking at the circuit itself. I know the meter is not a problem. It moves, and the previous servicing has improved it a bit. And the problem seems to lies on the ohms section. So I was looking at the ohm section and never seen this kind of before, but this kind of arrangement or switch before. But these are normal in multimeter. So not having any experience in repairing multimeter, I just look at the where does this link to on the FET board itself. So one end of the switch itself is eventually goes to A2. I'm going to explain what is A2 and what are these, maybe some of it, what are these writing here I'm jotting on the circuit, the schematic itself. And on the other end of these of the battery itself, it is in combination. This is the 1.5 volt battery. It is in some way or another in combination of the with the 9 volt battery. So you need the full 11 to 12 volts for the ohms setting, ohms position to work. Because if you want to measure resistance, you need some volts to yeah, measure across the resistance or resistor, yeah. So the other end of the one end of the battery goes to the resistor divider or voltage divider. The other end goes to not sure where I'm looking just now. Okay, goes to here. Okay, where does this I thought, yeah. So it eventually, this voltage divider goes to one resistor and then goes here and then goes there and then goes here and then goes to A3. So I measured here, I got a 1.6 volt. I measure A2, I got 1.6 volt. I measure here 1.6. Then I measure here, I got 2.5. So I thought I write it down. This B1 to B5 is the ribbon cable connecting between these two boards, and then this A1 to A5 is the other set of ribbon cable which connecting these two parts. In the end, what I measured here are just numbers that I couldn't understand, because when you measure voltage, you need something to refer to that tells you should have this voltage, and what do you get from that voltage. Is there different? The only voltage that I can understand is the where is it? The A4, which is this one. This itself is the voltage supply rail supplying the FET for it to work, and it also connects to the upwards area. So I look at it. I look at this array of this arrangement of transistor, and I beginning to understand. This looks really like an amplifier. So the collector of Q, what is this? Q, not sure what Q is that. Is the supply for this amplifier, I may say, to the to amplify tone to the buzzer. And because I do not know what voltage does this represent, I end up measuring the component itself one by one. Turn off the unit, started measuring these diodes, measured okay. And then when I reach this C1, which is a 47 nanofarad, it gives out around 31 to 33 nanofarad. So it's very off. Even on the component itself, it is how do you say? It is correspondent with the whatever written in the schematic. Sometimes on the schematic writes different from the actual component, but not in this case. The whatever written here is exactly found on the component itself. So I measured this. This comes low, and then after that I thought maybe I should check every component here, since it's easier for me to do that than trying to figure out what does what. And looking at the FET configuration, I noticed there is a similar circuit on the right and on the left. So same goes for the value. So I'm seeing C1 here, which is 47 nano, and then I see C4 also 47 nano. They are quite similarly apart and connect to the same leg of the each FET. And then I saw over here C2 and C3 is the same value, 47 nano, and then these two resistors are the same, 510 ohms. And then I see yeah, there's a lot of similarity from left to right, so I'm guessing this is a circuit that designed to be in balance with whatever should be in balance with left and right, in order to have a equal what do you say, equal tension could be, yeah. So and the resistor also, there's a 5.1 mega ohm here, which is R39. I wrote there. It's measuring 5.5, and on the same end, mirror end of it, is R29, which is also a 5.1 mega ohm. It measures 4.95. So at this point, since I already measure all the component here, everything checks out okay, including the FET single package itself, I'm concluding I'm going to change whatever that is suspicious. Yeah. So no point of me be trying to be an engineer, trying to figure out what does what in this circuit. It's better for me to just change whatever suspicious before I need to go to check the next board. I want to settle this board, because this board is quite easily disassembled, quite easily to take out, and yeah. So I've taken out the board itself. This is the daughter board. It is positioned this way. So broke one of the ribbon leg. No problem, I can redo that. So in case you are opening this, I want to show you something, so you won't be confused as I was. So when you look at the this circuit here, you're going to see A5, B4, B, and then A, and then two set A and B, A1 to A5 and B1 to B5. So yeah, so where's that? So you're going to see the ribbon cable is attached this way, and you're going to think the white color band is representing pin number 1. No, actually the pin number 1 is stamped on the circuit board itself. This is A, so therefore this is A1, 2, 3, 4, 5. So not A1 over here. This is the white band. Ignore this. Sometimes they mix around this thing. The actual pin reference is on the dot here. So A1, 2, 3, 4, 5. And then the next one is B1, 2, 3, 4, 5. It's good that this board has a lot of indication, as much detailed indication of the component, numbers, everything. But you have to be careful, because you can get confused. For instance, For instance, this one, when I saw this VR1, I thought this is VR1. But no, actually this is VR1. I took out this one and measure, and then when I took it out, I saw behind there, there's a VR1, sorry, VR2 stamp, yeah. So this is VR2, this is VR1. So you better be careful where you look at. Be sure to look around, because they really try to put the component marking on the board itself, quite appreciated, yeah. And yeah, so the capacitor that I told you about, those 47 nanofarad, they are situated previously here. There is C1, C4, and then C2 and C3. So those are the capacitors. So I'm thinking I want to change to to a better one. I think I will use either a polyester or polypropylene, not sure yet. So on there, if you can see, which is hard to see actually, even for me. So yeah, it's stamped there 473. So when I put this, when I measure this, it doesn't measure. It doesn't measure correct. So capacitor. I use my Chinese capacitor tester for this, but for this one I'm going to measure. Yeah, on this one it's measuring low. Not sure why. Yeah. Let's use the Chinesium tester. So we expect to see 47 nanofarad or 0.047, I think. So if you can see, not sure whether you can see or not. Yeah. So it's measuring in low. So this is well below 20% or beyond, not near enough the spec. Yeah, this is one of the capacitor. Since we have time, let's measure all four. (31.8 nanofarad). Yeah. Let's put it here. Let's see what this escort tells us. Yeah, too low than expected. Yeah. Third one, 13 minutes already. Not sure whether I should continue measuring this capacitor, but as proof, we need to do this. 32.16. Yeah. So I will change all four of these ceramic capacitor with polypropylene or polyester, whatever that fits the circuit board itself, and those two resistors that doesn't match in terms of value itself. Yeah, I'm going to change that also, which is the R39 and R29, which is supposed to be 5.1 mega ohm. So I will use plus minus 1%, because this circuit, I think, requires for in my thinking, this circuit itself I think requires a bit of precision, because when you look at this FET, both need to be in equal gain or balance or whatever. So whatever circuit or whatever component that attached to each side must be in what you say, in a close tolerance, yeah, for it to work well. So it will defeat the purpose if you use if they were to use a well matched FET, and then the external component is all over the place in terms of tolerance. So that's my belief now, and I will order the parts and we'll see what happened from there. And also I'm not neglecting the possibility the flaw might come from here also, and but I will leave this area after I've done I feel well confident that I have solved whatever anomaly or whatever that is not correct in the daughter board or in the sub PCB. So that's it, and until the next video, yeah.